Learning alphabets with data science. A for artificial neural network. It mimics the human brain's neural network. Hidden units of the hidden layer in the artificial neural network architecture can be thought of as neurons, and they introduce non-linearity with inputs and few biases. B for bagging, making multiple training sets from a training set and training separate models on those separate training sets and finally averaging them out. C is for correlation. It measures the relationship between two features or variables. D for deep learning. The cornerstone for deep learning is artificial neural networks. Whenever you have an artificial neural network with many hidden layers, it's most likely a deep learning problem which is being solved. E for error. In a supervised machine learning setup, you always have an actual number on which you're supervising the model and a predicted or an estimated number. And the difference between these two numbers is error. And you tend to minimize the error in these kinds of machine learning problems, which are kind of a supervised machine learning problem. F for feature. Call it feature, call it variable, call it input. All it means is what you feed into your data science models. G for gradient descent is a way to approximate global minima using local minimas, following an iterative approach. H for hypothesis testing. Using test statistic, you either reject the null hypothesis in the favor of alternate or fail to reject the null. I for intercept. Intercept in linear regression is that parameter which has the same impact for all inputs. So if you take a very simple example that your intercept is 3, the impact of intercept on y will always be 3 irrespective of x. J for Julia. It's the next breakthrough in data science programming, as it is specially designed for quantitative researchers or data scientists. K for KNN or K nearest neighbor, a method which can be adapted to both regression and classification. The key idea here is that you find K nearest points of any data point. Using this, you train your model. And most importantly, this is a non-parametric model. K here is the hyperparameter. L for linear regression. Linear regression is the most simple yet the most powerful predictive ML model. Its components are the intercept and the coefficients of all the features or predictors. M for model. It's an abstraction or simplification of reality using mathematics and statistics. N for normal distribution. Generally, people talk about normal distribution when they are new to data science. It is not the only statistical distribution of importance. There are others as well. To completely identify a normal distribution, you need its mean and variance. And a heuristic to understand whether a distribution is normal or not is that it will be symmetric about its mean. O for overfitting is prone to happen when the model is too complex, fits the training data well, but fails miserably when presented with new data. P-value measures the strength of rejection or failure to rejection. In statistical terms, observed level of significance. QQ plot compares to probability distributions. Generally, it's a test for normality. Random forest combines a number of decision trees similar to bagging with a twist on the choice of features while making the decision trees. S for SVD, along with PCA, is a dimension reduction technique, and if you feed into it P features, when P is very large, it gives you a smaller set of modified features, and in PCA terms, most important principal components, which helps you in reducing the dimensionality of the problem. T-test is a statistical test to compare means of two different groups. Underfitting is the opposite of overfitting. It's a deficient model which has missed out on important patterns or features while training the model. V for variance. It measures how spread the data is about the mean. So if a data set is 2, 2, 2, 2, 2, it will definitely have a very low variance, which in this case will be 0. But if let's say data is 2, 5, 10, 15, 30, definitely its variance is going to be very high and not going to be 0. W for web scraping. It's a risky way to get data from websites, hence read all the possible violations while doing web scraping. Better to be safe than sorry. X for inputs, Y for outputs. X what you know, Y what you need to know. Z for Z-score. It measures how far a data point is from the mean in terms of standard deviation. Just subtract the mean from the data point and divide it by the standard deviation. And if it gives you, let's say, like 2, it means the data point is 2 standard deviations away from the mean.